Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter and last chapter of 12th. And this chapter is Chemistry in Everyday Life. This is the new chapter and last chapter for your course, 12th course. Chemistry in Everyday Life. This is very interesting chapter, and here you will study role of chemistry in our life. We have studied many chapters and we have learned so many things, means a basic principle of chemistry, and also realize that it influences every sphere of human life. The principle of chemistry have been used for the benefit of mankind. Now think for cleanliness. If you think for cleanliness, then many things will come to your mind. The materials like soaps, detergents, household bleaches, toothpaste, etc. will come to your mind. Means from morning to evening before bed you are using many products of chemicals, or you can tell chemistry products. Now think for beautiful clothes. Then immediately chemicals of the synthetic fibers used for making cloth and chemicals giving color to them will come to your mind. Now think for food materials. Again, number of chemicals about which you have learned in the carbohydrate chapters. Carbohydrate chapters, protein chapters, fat, you have seen many food materials, glucose, fructose, sucrose, maltose, all are food materials. Protein also, fat also. Okay. Now think for the sickness and disease. Then it reminds us of medicines, again chemicals. If you think for explosives, fuels, rocket propellants, building and electronic materials, all are chemicals. Means explosive fuels, rocket propellants, building and electronic materials, etc. are all chemicals. Chemistry has influenced our life so much that we don't even realize that we come across chemicals at every moment. Here we will focus more on application of chemistry in three important and interesting areas, namely medicines, food materials, and cleansing agents. Main focus will be on this area. Now I am going to discuss about drugs and their classification. Drugs are chemicals of low molecular masses, means between 100 to 500 unit. These interact with macromolecular targets. Here listen, these drugs, or you can, now I told you drugs are chemicals of low molecular masses, very low, roughly between 100 to 500 U. These drugs interact with macromolecular target, MAC, macro, not micro, macromolecular targets and produce a biological response. When the biological response is therapeutic and useful, these chemicals are called medicines and are used in diagnosis, prevention and treatment of disease. If taken in doses higher than those recommended, most of the drugs used as medicines are potential poisons. Remember it. Differences also. Drugs and medicine. What are the differences? That also now here only you can understand. That chemicals, I told you that when the biological response is therapeutic and useful, these chemicals are called medicine and are used in diagnosis, prevention and treatment of disease. If taken in doses higher than those recommended, most of the drugs used as medicines are potential poisons. Means drugs should not take in excess. It will give negative effect. If it is used in a restricted amount, recommended amount, then that drugs is called medicine. Okay. Again, I am telling entire things because it is very, very important. Drugs are chemicals of low molecular masses. These interact with macromolecular targets and produce a biological response. When the biological response is therapeutic and useful, these chemicals are called medicines and are used in diagnosis, prevention and treatment of diseases. If taken in doses higher than those recommended, most of the drugs used as medicines are potential poisons. Use of chemicals for therapeutic effect is called chemotherapy. What is the chemotherapy? Then use of chemicals for therapeutic effect, T-H-E-R-A, therapeutic, P-U-T-I-C. Correct? Use of chemicals for therapeutic effect is called chemotherapy. Now I am telling you classification of drugs. Drugs can be classified mainly in criteria. I am telling you that criteria. First, on the basis of pharmacological effect. Drugs can be classified mainly on criteria. First criteria is on the basis of pharmacological effect. Second criteria is on the basis of drug action. And third, on the basis of chemical structure. And fourth, on the basis of molecular target. Just like your target objective. Motto, like that, where on the basis of molecular targets. Now, one by one, I am telling you little details. First, on the basis of pharmacological effect. Many drugs are there. Then you can divide on these basis, on these criteria. Then first criteria, that is on the basis of pharmacological effect. This classification is based on pharmacological effect of the drugs. It is useful for doctors because it provides them the whole range of drug available for the treatment of a particular type of problem. For example, analgesics have pain-killing effect. Antiseptic kill or arrest the growth of microorganisms. Now second, on the basis of drug action. It is based on the action of drug on a particular biochemical processes. For example, all antihistamines inhibit the action of the compound histamine, which causes inflammation in the body. Correct? There are various ways in which action of histamines can be blocked. Okay. Again, I am telling you that on the basis of drug action, it is based on the action of drug on a particular biochemical process. For example, all antihistamines inhibit, means slowed down. It slows down. Then, for example, all antihistamines inhibit the action of the compound histamine, which causes inflammation of the body. Actually, due to the histamine, it will cause inflammation in the body, swelling like that. Okay. Then this antihistamine, actually histamine, which causes inflammation of the body, then antihistamine it will do in a reverse way. Means antihistamines, or you can tell, first to understand these things, I will tell in details about the antihistamines at proper place. But here you know that there are various ways in which action of histamines can be blocked. Okay, many ways are there to block the action of histamines. Okay, there are various ways in which action of histamines can be blocked. I will discuss in details in proper place. Now third classification, on the basis of chemical structure. It is based on the chemical structure of the drug. Drugs classified in this way share common structural feature and often have similar pharmacological activity. For example, sulfonamides have common structural feature. What is the structure? Now I am telling you that one benzene ring is there, and at ortho position SO2 is there, and from the S NHR is attached. At ortho position sulfur is attached, means SO2 is attached, and only from the sulfur NHR is attached, means S is attached with the benzene ring, and with that S 2 oxygen is attached with a double bond, 2 oxygen, and only from that sulfur NHR is attached. Correct? R means alkyl group, N means nitrogen, you know, S means sulfur, and at para position NH2 is there. Para position NH2 is there. Then this is the common structural feature. Okay, this is actually sulfonamides. Sulfonamides have common structural feature, I told you. Now fourth classification, on the basis of molecular targets. On the basis of molecular targets, drugs usually interact with biomolecules such as carbohydrates, lipids, proteins, and nucleic acids. Correct? Drugs usually interact with biomolecules such as carbohydrates, lipids, proteins and nucleic acid. These are called target molecules or drug targets. Understood what is the molecular target? Carbohydrate, lipids, proteins, nucleic acid. These are called target molecules or drug targets. Drugs possessing some common structural feature may have the same mechanism of action on targets. The classification based on the molecular target is the most useful classification for medicinal chemists. Now just to come to the drug target interaction. Drug target interaction. How drug target the, what will be the interaction of drug when it will attack to the target. That is called drug target interaction. How is drug is going to interact with the target. Macro, big. MIC, macro means small, and MAC, macro, means big. Then macro, big I am talking about. Macromolecules of biological origin perform various functions in the body. For example, proteins, which perform the role of biological catalysis in the body, are called enzymes. Those which are crucial to communication system in the body are called receptors. Both are protein only. Again I am telling you that macromolecules of biological origin perform various functions in the body. For example, proteins. See the you can say dual role of proteins. Proteins which perform the role of biological catalyst in the body are called enzymes. Those which are crucial to the communication system in the body are called receptors. Carriers proteins. Third, you can see, third way how you can say function you can tell. Now third, carrier proteins carry polar molecules across the cell membranes. Okay. Nucleic acids have coded genetic information for the cell. Lipids and carbohydrates are a structural part of the cell membrane. Okay. Now I will explain the drug target interaction with examples of enzyme and receptors. And now enzyme as drug targets. Now I will discuss enzymes as drug targets. In that I will discuss catalytic action of enzymes. Catalytic action of enzymes. Already I have discussed, you can say, action of catalyst mechanism many times I have discussed, because it is also catalyst, biological catalyst. Enzyme is a catalyst, because this will work inside the body. Inside the body, full reactions, many reactions will be going on. Actually, life is full of reaction. And when reaction is going on, then catalyst is required. Then inside the body, catalyst is known as biological catalyst. Okay. Then mechanism is similar. For understanding the interaction between drug and an enzyme, it is important to know that how enzyme catalyze the reaction. Already we have discussed in details. In their catalytic activity, enzymes perform two major functions. You remember. First, the first function of an enzyme is to hold the substrate for a chemical reaction. active site of enzyme hold the substrate molecules. Active sites of how it will function, I am telling you, that is little different. That first I am telling you the first function of an enzyme is to hold the substrate. Substrate means molecules or compound, okay, which will come near the enzyme. Then enzyme will hold that molecule or compound, and that molecule or compound reacting substance is called substrate. Particularly in organic chemistry, that substance is called substrate. Means you can say just like reactants A and B, like that way. The first function of an enzyme is to hold the substrate for a chemical reaction. Active site of enzymes hold the substrate molecule in a suitable position so that it can be attacked by a reagent effectively. Okay, means that reagent, near the reagent substrate will come, then it will hold it, and then other reagent will come and will react with this substrate. Okay, this you remember. Active sites of enzymes hold the substrate molecule in a suitable position so that it can be attached. It can be attacked or attached, anything you can tell. It can be attacked by the reagent effectively in suitable position. Okay, that substrate will be, enzyme will hold the substrate in a suitable position so that reagent should come and attack there. Substrates bind the active site of the enzyme through a variety of interaction such as ionic bonding, hydrogen bonding, van der Waals interaction, or dipole-dipole interaction. How enzyme will hold this substrate? Then what I told you, 4 ways. Substrates bind the active site of the enzyme, means between the substrate and enzyme, how they will bind to each other. Then they will bind through a variety of interaction such as first ionic bonding, second hydrogen bonding, third van der Waals interaction, fourth dipole-dipole interaction. Okay. Now second function I am telling you, that you can understand like that, key, lock, lock. In a lock you are putting the key. All key can't go to the lock. A special key only can enter. Correct? This is a 99% you can tell. This is the situation of substrate and enzyme. They will hold like that way. For each lock, one key will be there, a special. Means a special structure will be there. There only substrate can fit, and then reagent will attack. Second function I am telling you, that the second function of enzyme is to provide functional group that will attack the substrate and carry out chemical reaction. As soon as that reagent will attack to the substrate, chemical reaction will start. Then enzyme is just like a lock enzyme. There is, in that you will insert the key. Then key is here just like a substrate. Correct? And hole in a lock where you will insert the key, that is just like a enzyme active site. that is called enzyme active site. In that active site, substrate will fit there, just like a key. Correct? And both will, when you are inserting key in the lock, that is called enzyme holding substrate. That situation you can tell enzyme holding substrate. Okay. Then this I told you about the mechanism. Then here in this situation, after that second function I told you, the second function of an enzyme is to provide functional group that will attack the substrate and carry out chemical reaction. You know that generally these functional groups are responsible for reaction. This group should touch, or through that group should attack to the substrate. Okay. Reagent has some group, functional group that should touch to the substrate through that way only. Now second I am talking drug enzyme interaction. Drug enzyme interaction. Okay, actually enzyme as drug targets. First step I told you, catalytic action of enzyme. There are two functions already discussed. Now drug enzyme interaction. Now see, now you have inserted the key in the this lock. After that, simply if you will put, nothing will happen. You have to move left or right, something you have to do, okay, to open the lock. Like that situation is here. That is called drug enzyme interaction. Drugs inhibit any of the you can say mentioned activities of enzyme. What function I told you, that is actually activities. Then drugs inhibit, actually what I told, that is the reaction. And if you actually any medicine and drugs, what is its role? That you want to cure the medicine, you want to cure the disease, correct? Then suppose due to some reaction this problem is there, what you are facing the problem, either high fever, headache, stomach pain, anything, then you want just this problem should go. Then for all this reaction, for all the things, problem, some reaction will be going on. Then you want to stop that reaction, correct? And now in that sense, now you understand drugs, how it controls the disease, that I am telling you. Action. Drugs inhibit the attachment of substrate on active site of enzymes in two different ways. Actually their function is that now this substrate and reagent should not react, because reagent will attack, only then you will have problem. And that reaction should not go, should not continue, it should stop. Then in two ways that drugs will attack, it's role I am talking about, how it will control. Then in first step, what it will do, that first step, drugs compete with natural substrate. Okay, drugs compete with natural substrates for their attachment of the active sites of enzymes. There will be competition with drugs and substrate, which will go there, which will reach to the just like a lock. If wanted to there fit, but now drugs will not allow. There will be competition, it will go first. Then or substrate, you can say, suppose already that substrate is there, then reagent want to touch, then now this drugs will go, there will be competition, it will reach first, then substrate will reagent will not touch to the substrate because already drugs are there. Drugs molecules reached there. Then reagent will not touch there. Then reaction will be stopped. Correct? Because now in the place of reagent, drugs has reached fast. Correct? That's why now that reaction which was going on will be stopped. Then drugs compete with the natural substrates for their attachment on the active site of enzyme. Such drugs are called competitive inhibitors. Competitive inhibitors. INHIBITORS. Inhibitors means will make slow down. Sometimes it can stop. Correct? Then already I told you enzyme and substrate both will fit to each other, and after that drugs will in the absence of drug reagent will attack there. But if drug is there, then drug will attach the substrate, not the reagent. Okay, substrate will go out, it will be not reach there. There drug will reach first. Correct? Then drug blocks the active site of enzyme. Then substrate will not attach there, will not react there. It will, it will not go there. Now second action I am telling you. Some drugs do not bind the enzyme's active site. These bind to a different site of enzyme. See now, second way how you can say drugs, how drugs means drugs action. Second way you understand. Some drugs do not bind the enzyme's active site. These bind to a different site of enzyme, which is called allosteric site. Allosteric site. ALLOSTERIC. Allosteric site. Other side it will attack. It will bind with these drugs bind to a different site of enzyme. That site is called allosteric site. Allosteric site. This binding of inhibitor at allosteric site change the shape of active site in such a way that substrate can not recognize it. Now actually I told you that substrate should adjust, it should fit to the certain shape will be there it should fit. Correct? Then other action of the drugs that it will attack from the other site. Okay, it will bind to a different site of enzyme. This binding of inhibitor at allosteric site change the shape of the active site. When shape will change, where substance was there, then now shape will change, then it will not fit, then it will not react. It will, because enzyme they is attacking which other side, then their substrate, a special shape will change. Means just like in lock, that now lock that says that hole is now changed, then this will not fit, key will not fit. Correct? And this is happening because now drugs is attacking or binding with other sites. That is called allosteric site. This binding of inhibitor at allosteric site change the shape of the active site in such a way that substrate cannot recognize it. If the bond formed between an enzyme and inhibitor is a strong covalent bond. It will form some bond. Then now, if the bond formed between an enzyme and an inhibitor is a strong covalent bond and cannot be broken easily, then the enzyme is blocked permanently. Enzyme is blocked permanently. The body then degrades the enzyme inhibitor complex and synthesis the new enzyme. Correct? Means here bond is formed. Then a strong bond they will form. Then when bond is formed, then covalent bond and covalent bond particularly it forms a covalent bond. Means a bond formed between an enzyme and an inhibitor. Inhibitor means a catalyst, what we are telling in a negative sense. Correct? Bond formed between an enzyme and an inhibitor is, if it is a strong covalent bond, and in this case it can't be broken easily. When it is a strong covalent bond, then this bond will not break easily. Then the enzyme is blocked. Enzyme is blocked permanently. The body then degrades the enzyme inhibitor complex. Okay, this reaction will not take place. Degrade the enzyme inhibitor complex and synthesizes the new enzyme. This I told the action. Drug action, I told you that how this drug and enzyme interact, I have told you. Now come to the receptors as drug targets. Receptors as drug target. Already I told you that this receptor like a carbohydrate, lipids, proteins, correct? Then receptors as drug targets. Receptors are proteins, correct? Receptors are proteins that are crucial to body communication process. Majority of these are embedded in a cell membrane. You remember, majority of these are means protein. Majority of proteins are embedded in the cell membrane. Receptor proteins are embedded in the cell membrane in such a way that their small part possessing active site projects out of the surface of the membrane and opens on the outside region of the cell membrane. Correct? In a cell, that these proteins will come out, outer surface, like that situation. Correct? These proteins will be just like outside, out of cell, their surface. It will be on the surface but outside. This you have to remember. Receptor molecular protein are embedded in the cell membranes in such a way that their small part possessing active site projects out of the surface of the membrane and opens on the out regions of the cell membrane. In the body, message between two neurons and that between neurons to muscles. This you remember. Actually, in our body, many neurons will be there. One particle is there, special particles. In the body, in very small particles. I will tell later on details about neurons. In the body, message between two neurons, and that between neurons and to neurons to muscle is communicated through certain chemicals. Okay, it is related to communication. Neurons are related to communication. Then here in the body, message you have to send from one neuron to the other neuron, or from one neuron to the muscles. Correct? Then that time what will happen, I am telling you. In the body, message between two neurons, neuron neurons, neurons, not neutron, neurons, and the between neurons to muscle is communicated through a certain chemicals. These chemicals known as chemical messenger. Just like messenger will tell to the postman, or I will come and will tell something, I'll give letter, or whatever we post is there, they will deliver to us, and you will get information. That is the mind. But here, that sense only you can understand. That these chemicals are known as chemical messenger. Okay, again I am telling you that message between two neurons and that between neurons to the muscle is communicated through certain chemicals, just like a postman, certain chemicals. These chemicals known as chemical messengers are received at the bonding site of receptor protein. Correct? That will be received by receptor protein. Chemical messenger, understood, that are received at the binding sites of receptor proteins. To accommodate a messenger shape of the receptor site change. To accommodate a messenger, when a messenger, just like for your understanding purpose, postman, correct? He will give some chair to sit, like that sense you take only. To accommodate a messenger shape of the receptor site change. This brings about the transfer of message into the cell. Thus, chemical messenger gives message to the cell without entering the cell. Just like postman, it will not allow to go inside the room. Near the door only you can give, ask him to sit there. If some important post is there, then it will take time, then you will ask just to sit. You will give some chair, sit, and then work you do. Like that way, you will not allow to enter the room in that sense. Okay. Chemicals messengers give a message to the cell without entering the cell. Okay. Now, actually by diagram you will understand quickly. I will try to send it, that diagram also. Now, there are a large number of different receptors in the body that interact with different chemical messenger. These receptors show selectivity for one chemical messenger over to the other because their binding sites have different shape, structure, and amino acid composition. Many different type of amino acids are there. Okay. Then here you should understand a large number of different receptors. There are a large number of different receptors in the body that interact with different chemical messenger. These receptors show selectivity for one chemical messenger over other because their binding sites have different shape, structure, and amino acid composition. Drugs that bind the receptor site, drugs that bind to the receptor site and inhibit its natural function are called antagonists. ANTA, anta, GONISTS, antagonist, anta, GONISTS, correct? Antagonists. Then this understands. Now drug will also play same type of role what I discussed. Here also some competition will be there. Okay. Drugs that bind to the receptor site and inhibits means will stop or will make it slow. Reaction will make it slow or it will stop that reaction. Originally what it was supposed to go, that reaction it will stop. Then drugs that bind to receptor site and inhibit its natural function are called antagonists. These are useful when blocking of message is required. There are other types of drugs that mimic the natural messenger by switching on the receptor. These are called agonists. Okay. There are other type of drugs that mimic the natural messenger by switching on the receptor. These are called agonists. These are useful when there is a lack of natural chemical messenger. Okay. And now I will discuss about, but it will take more time. Next class. Today is the first day for this chapter. Next class again I will continue. Here all chapters are all terms are very, very important and very, very interesting also. Okay. Slowly and slowly I will discuss all terms. Thank you.